All right, this is lesson 6.5. Conditions for rhombuses, rectangles, and squares. So we're going to learn how to determine whether a parallelogram is a rhombus or a rectangle. All right, do the review, check back with your answers. All right, so here's some theorems we're going to use. If the diagonals of a parallelogram are perpendicular, then the parallelogram is a rhombus. If one diagonal of the parallelogram bisects a pair of opposite angles, then the parallelogram is a rhombus. So that means that these diagonals are perpendicular, so we can put a symbol in there. And that also means that these four angles are congruent, because we know opposite angles in a parallelogram are congruent, and we know they're bisecting because it's a rhombus. So number 8, if ABCD is a parallelogram and AC is perpendicular to BD, then it is a rhombus. If ABCD is a parallelogram, then angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4, then it is a rhombus. If the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. So we're going to insert some. We also know, since it's a parallelogram, that they bisect each other, so we can say this. Those are all congruent. If ABCD is a parallelogram and BD is congruent to AC, then ABCD is a rectangle. The parallelogram that has diagonals that are both perpendicular and congruent is a square. All right, problem 1. Can you conclude that the parallelogram is a rhombus, rectangle, or square? Explain. Well, here we have congruent pieces in the diagonal, and they're the same here. So adding 7 plus 7, and both of them equals 7 plus 7, so we can conclude that this parallelogram is a rectangle, because the diagonals are congruent. And in this one, we know that all these angles are going to be 90 degrees, and if the diagonals of a quadrilateral or parallelogram are perpendicular, then we know that that quadrilateral is a rhombus. All right. For number 13, it says draw a parallelogram in the box below, label the angles with their measures, use a protractor to help make accurate angle measures. If you have a protractor, you can go ahead and do that. I'm just going to make a rough sketch of this. So we need angles of 20, 160, 20, and 160. I'm just going to kind of guess there. Maybe something like that. All right. So we know these smaller ones are 20, and the larger ones are 160. All right. So you do, given the information, you do not know the lengths of the sides of the parallelogram. You do not know the lengths of the diagonals. The angles of the rectangle are all, of a rectangle are all right angles. So we know this isn't a rectangle. The angles of the square are all right angles. And we conclude that this parallelogram is a rhombus, a rectangle, or a square. We can't conclude any of those. We would need to know that all the sides are congruent to conclude that it's a rhombus, and we don't have that. For what value of x is parallelogram ABCD a square? Well, if it's a square, that means that all the sides are congruent, which means it's a rhombus. And we know from the earlier theorems that the diagonals are perpendicular in a rhombus. So that means that each of these angles are 90 degrees. So from that information, we can say that 6x plus 6 is equal to 90. Using the subtraction property of equality, we get 6x is 84. Dividing both sides by 6, we get x is equal to 14. Or what value y is parallelogram DEFG a rectangle? For parallelogram DEFG to be a parallelogram, the diagonals must be, they must bisect each other. So EG is equal to 2 times 5y plus 3. So 10y is equals 10y, EG equals 10y plus 6 if we use the distributive property. DEF is equal to 2 times the quantity 7y minus 5, which is equal to 14y minus 10. For DEFG to be a rectangle, the diagonals must be congruent. So to solve for y, we can write this equation. And then solving it, we could subtract 10y from both sides. And that gives us 4y minus 10. Adding 10 to both sides gives us 16 equals 4y. And dividing both sides by 4 gives us y is equal to 4. All right. Describe how you can use 2 strings to mark 4 corners of a rectangle. To do this, what we could do is use the idea that if it's a rectangle, then the diagonals are congruent. And since it's a quadrilateral, the diagonals bisect each other. So if we think about that, what we could do is we could cut 2 strings. So let's say that's one string, and there's another string, and we're going to cut them at exactly the same length. So start by cutting 2 strings to the same length. Okay, now that we have that, what you would do is find the midpoint of each of those strings. And the way you could do that is just fold the strings in half. So we're going to find the midpoint of the strings and mark them. And we could do that just by folding them in half, and what I mean by that is if I did this with the strings and matched up the ends, then I would know where the midpoint is, and then I could put a little mark, like maybe a ribbon in on each string. So now, let's say we have those 2 strings that are marked with the midpoint on them. Okay. Then we are going to stretch out those 2 strings. So I'm going to take those 2 strings and stretch them out we're going to need 4 people to do this, but I'm going to put one of the strings like this, so I'm not changing the length, and then I'm going to take the other string like this, and I'm going to make sure that they intersect at the midpoints. So wherever the strings are marked, we'll make sure that they're crossing right there and intersecting at the midpoint. And then I'm just going to mark on the ground those 4 corners. And when I connect those lines, I'll have a rectangle. All right, this next problem kind of goes through the same idea. Suppose you are on volunteer building team at Wright. You are helping to lay out a square play area. How can you use the property of diagonals to locate the 4 corners? You can cut 2 pieces of rope that will be the diagonals of the square play area. Cut them the same length because a parallelogram is a rectangle if the diagonals are congruent. You join 2 pieces of rope at their midpoints because a quadrilateral is a parallelogram. If the diagonals bisect each other. You move so the diagonals are perpendicular because a parallelogram is a square, actually a rhombus. If the diagonals are perpendicular, and the polygon is a square because a rhombus, that's a rectangle, is a square. Okay? All right, last thing, we are going to name all the special parallelograms we learned about and put these properties in here. A being the diagonals are perpendicular, B diagonals are congruent, C diagonals are angle bisectors, D diagonals bisect each other, and E diagonals are perpendicular bisectors of each other. So go ahead and fill this chart in ahead of time and see if you're right. All right, and I'll see you tomorrow.